Hello, third grade, and welcome to lesson 5-6, Look for and Use Structure. Let's go ahead and watch our short lesson video, and then we're going to explain how we look for structure and how we use it to help us solve different questions.
How can you use the structure of mathematics to solve problems? Think about this question during the lesson. How can you tell, without computing, whether the symbol greater than, less than, or is equal to should be placed in each circle? You do not have to compute. You can use the structure of the number system to compare two expressions. What does it mean to compare expressions?
All right, here, when we're comparing expressions, we're trying to figure out which one is greater than or less than. Now, they told you don't need to compute. What they mean by that is it means you don't need to solve to figure out which one is greater. Now, the easy thing that you can do is take a look at the digits on each side. If the digits are the same, look at the next digit and the next digit and the next digit until you find ones that are different. If all of the digits are the same, then both sides are going to be equal or balanced. If you have a side that has a digit that's greater than the digits on the other side, you already know which side is going to be the greater than side. So for number one, both sides have a 4 in it. Both sides have a 5 in it, but one side has a 2 and the other side has a 3. Now, because the 4 and the 5 are the same in both, I'm going to ignore them. I'm going to look just at that 2 and that 3. I know 3 is greater than 2, so 4 times 5 times 2 is going to be less than 4 times 3 times 5. Now for number 2, take a look at the digits you have. You have 6 times 7 on one side, and you have 7 times 6 on the other side. Remember your properties. Remember that the commutative property of multiplication tells us that we can switch our numbers and our product will stay the same. So 6 times 7 is going to have the same product. It's going to be equal to 7 times 6.
It means that you will look at both expressions to see if they are equal to each other, or if one is greater than or less than the other. Think, what do I need to do to complete this task? I need to compare the two expressions in each problem. Instead of doing any calculations, I will look at the values of the factors in each expression. Think, how can I make use of structure to solve this problem? I can think about properties I know, look for patterns and use them as needed. Here's my thinking. Some factors in the expressions are the same and some are different. I will use this to help me compare the two expressions. In problem 1, I know that I can group factors in any way. So I can rewrite one expression How does grouping the factors in a different way help you solve the problem?
Now notice what they did. Here they used their associative property, right? Because we're working with more than two numbers. They use their associative property to switch up the order of the factors on the right side. So the first one was 4 times 5 times 2. The second one, they rearranged it so it was 4 times 5 times 3. Now the 4 and the 5, we can ignore those because we know those are both equal to 20. So the only factor that we have left to compare are the 2 and the 3 because those are the only ones that are different from each other. And right away, without solving, you already know 3 is greater than 2. So the second expression is greater than the first one. The first one is less than the second one.
By rewriting one expression as 4 times 5 times 3, you have grouped 4 times 5 together in both expressions. You immediately see that 2 is less than 3. so you can tell what the symbol in the circle should be without computing. In problem 2, I see the factors are the same on both sides. I know this means that the products are the same. What property of multiplication tells you that 6 times 7 is equal to 7 times 6 without computing?
Select your answer.
The factors are the same, and the commutative property of multiplication says that the order of the factors does not affect the product.
Now you know how you can use the structure of mathematics to compare expressions.
Let's go ahead and take a look at our notes, and then we're going to work on our guided practice. So 5-6, look for and use structure. So when you're looking for structure, ask yourself, what patterns do I see? How can I use these patterns to help me? Can I solve it in a different way to check my answer? Are there any properties that I know that can help me figure out the answer to this problem? So can you spot the pattern in our example below? What is the pattern and what numbers go into our empty boxes? So this is one of the questions. It's very similar to what you have in your book. Now, if 6 times 1 is equal to 3 times 2, we know 6 times 1 is 6 and 3 times 2 is also 6. Now, 6 times 2 is also equal to 3 times 4. And then we have 6 times 3 is equal to 3 times something. So what pattern do I see? I'm noticing that each time I increase the factor on the left side of the equation by 1, the factor that's missing on the right side is doubled whatever it was on the left side. So 6 times 1, this 1 is a 2 over here. This 2 over here is a 4. This 3 becomes a 6. So anytime I increase the factor on the left side of the equation, the factor on the right side is doubled. So 6 times 4 is going to be equal to 3 times 8. 6 times 5 is going to be equal to 3 times 10. So over here, 6 times 1 and 3 times 2, the 2 is double of 1. For the second one, 4 is the double of 2. For the next one, 6 is the double of 3, and so on. How can I use this pattern to solve and fill in the missing numbers? So I can continue filling in the factors on the left and increase by increasing that second factor by 1, while I fill in the factors on the right and increase the second factor by 2, or make it twice as much. I double it. Then I can do the math to check if my answers are correct. So 6 times 4, we said, is equal to 3 times 8. We filled in these missing digits. So I'm going to solve on the side. I know 6 times 4 is 24. 3 times 8 is also 24. Then I had 6 times 5 and 3 times 10. 6 times 5 is equal to 30. 3 times 10 is also equal to 30. These two are also equal to each other. So 8, we saw over here, is the double of 4, and 10 is the double of 5, and so on. You see that pattern as you go through. 2 is a double of 1, 4 is a double of 2, 6 is a double of 3. Now, how can you tell without solving if an equation is greater than, less than, or equal to another equation? So this is like the example that we did in our short video. So first thing you have to do, look at all the factors. Find the ones that are different and compare those, and then use the properties you know to solve. So this is the same one that you guys had in your example video. We're going to go through the steps again. Identify what is the same and what is different in each. So they both have a 4 and a 5 in them. 4 and 5 are factors in both sides of the equation. What's different is the one on the right has 2, or sorry, the one on the left has 2 as a factor, and the one on the right has 3 as a factor. So then we're going to use what we know, what facts, what properties, and so on to help us solve. So I know 2 is greater than 3. And since that's the only difference between the two equations, I know 4 times 5 times 2 is less than 4 times 5 times 3. I reorganize these numbers using that associative property because the 4 and the 4 times 5 is the same on both. So I can ignore the 4 and the 5 on both. And then I'm left just comparing 2 and 3. Now for your guided practice, it tells you 48 divided by 8, and you want to compare that to 48 divided by 6. So how can you decide without solving how to compare these numbers? So think about these for a minute. If you're sharing with 8 people for this group, and you're sharing with 6 people for this group, which group is going to have more? The group that's going to have more is when there are fewer groups, because you're able to give more to each one of those groups. But the more groups you have, the less you can put into each group. So I know that when I divide into more groups, each group will have less. The bigger my divisor is, the smaller my quotient will be. So since 8 is greater than 6, my answer over here is going to be less than my answer over here. And for question number 2, it said, whose friends received more stickers? Write greater than, less than, or equal to for the equation above. So this is the equation they're talking about. If they had 48 stickers, Nicole's friends, Nicole wanted to share her stickers with 6 friends, and our other character in the story wanted to share his stickers with 8 friends. They asked which one will get more. So if you're dividing, Nicole's friends are going to get more stickers because she's sharing with fewer people. So each friend is going to get more stickers. The other one is sharing with more people. So each friend will get fewer stickers. So remember, your dividend is the same in both. You're looking at your divisor. If you're sharing with more people, or for example, if this is a bunch of cookies and you're sharing it with 8 friends, they're going to get fewer cookies than if you were sharing it with 6 friends. So the smaller the groups are, the fewer number of groups you have, or the fewer friends that you're sharing with, the more each one of those friends is going to receive. That is it for this lesson. Again, this is reviewing properties and strategies that we've talked about before. We're using things that we know to help us solve. Remember, look for patterns, think about how to use those patterns, try to identify different strategies that you've used before, look for properties that you can use, and all of that information together will help you solve these different questions. If you have any other questions, let me know, 3rd grade. Otherwise, I hope you have a wonderful day. Take care. Bye-bye.